For generations, sharks have been portrayed as monsters, silent killers, mindless predators driven only by hunger and blood. That image is deeply rooted in human fear. Movies, headlines, and viral stories have shaped how we see sharks. Rows of sharp teeth, cold black eyes, sudden attacks from the deep. But the real story of sharks is far more complex and far more important. Sharks are not villains of the ocean. They are ancient survivors, perfectly adapted predators that play a critical role in maintaining life beneath the waves. Some sharks can detect electrical signals from living beings. Some can migrate thousands of miles across open oceans. Some can survive in rivers and lakes. And some species have existed almost unchanged for hundreds of millions of years. Today, we begin a journey into the true world of sharks. Not the myth, not the movie monster, but the real animal. This documentary explores how sharks evolved, how they hunt, why attacks occur, and what would happen if sharks vanished forever. Stay until the end, because the truth about sharks challenges everything we think we know about the ocean. Sharks are older than dinosaurs. They existed more than 400 million years ago, long before the first trees appeared on land. At a time when Earth's oceans were filled with strange and primitive life forms, sharks were already becoming efficient predators. They survived dramatic changes in climate. They survived shifting continents. They survived 5 mass extinction events. Most species did not. So why did sharks endure when so many others disappeared? The answer lies in their design. Unlike most fish, sharks do not have bones. Their skeletons are made of cartilage, the same flexible material found in human noses and ears. This makes their bodies lighter and more agile. It allows them to glide through water with minimal effort. Their skin is covered in tiny tooth-like structures called dermal denticles. These reduce drag and turbulence. They also protect sharks from parasites and injury. Every part of a shark's body serves a purpose. Over millions of years, evolution refined sharks into one of the most efficient predators on the planet. When an animal's design remains nearly unchanged for hundreds of millions of years, it means one thing: nature has little left to improve. Sharks are not fast by accident. Their powerful tails provide sudden bursts of speed. Their pectoral fins stabilize movement. Their dorsal fin prevents rolling. But strength alone does not explain their success. Sharks are masters of energy conservation. Many species glide effortlessly, using ocean currents to travel long distances. Some must keep swimming to breathe, forcing water across their gills. Others can rest motionless on the seafloor. Their teeth are not fixed. They are constantly replaced. A single shark can lose tens of thousands of teeth over its lifetime. As one tooth falls out, another moves forward to replace it. This ensures that sharks are always equipped to feed. Different species have different teeth, sharp and serrated for slicing flesh, flat and crushing for breaking shells, needle-like for gripping slippery prey. Each tooth reflects a specific hunting strategy. Sharks are not generalists by accident. They are specialists shaped by their environment. One of the greatest misconceptions about sharks is that they are simple-minded animals. In reality, sharks possess highly developed sensory systems. Their sense of smell is extraordinary. They can detect tiny concentrations of chemicals in the water. But smell alone does not guide a shark. Sharks can hear low-frequency vibrations from great distances. Struggling fish, splashing prey, movement in the water. Their lateral line system allows them to sense pressure changes. This helps them detect movement even in complete darkness. But the most remarkable sense of all is electroreception. Hidden along a shark's snout are tiny pores called ampullae. These organs detect electrical fields produced by living organisms. Every muscle contraction creates an electrical signal. Every heartbeat sends a pulse. Even buried prey cannot hide from this sense. In the final moments of an attack, sharks rely on electroreception more than sight. This sense makes sharks incredibly precise hunters. But it also explains why mistakes happen. Sharks do not hunt in a frenzy. They do not charge blindly at anything that moves. They investigate. A shark often approaches cautiously, circling its target. It observes. It senses. When a shark bites a human, it is rarely intentional predation. Most attacks are test bites. A single bite allows the shark to gather information: taste, texture, fat content. Humans are not natural prey for sharks. We lack the blubber of seals. We lack the fat reserves sharks seek. That is why most shark attacks end after one bite. Unfortunately, even a single bite from a large shark can be catastrophic. But the shark is not trying to kill a human. It is trying to identify what it has encountered. This distinction is critical to understanding shark behavior. Out of more than 500 shark species, only a handful are involved in attacks on humans. The great white shark is the most famous. Large, powerful, capable of breaching the surface of the water. Great whites specialize in hunting marine mammals. Their attacks on humans are usually cases of mistaken identity. The tiger shark is less selective. It consumes a wide variety of objects. Fish, turtles, birds, and human debris have all been found in its stomach. The bull shark is considered the most dangerous to humans. It is aggressive, territorial, and uniquely capable of surviving in fresh water. Bull sharks have been found in rivers far from the ocean. This ability brings them into closer contact with humans. But danger is not the same as intent. Sharks do not seek humans. They encounter us. For most of human history, sharks were rarely encountered. Early humans fished near shore. Sharks lived mostly beyond their reach. As technology advanced, humans entered deeper waters. Surfing, swimming, commercial fishing. The more time humans spend in the ocean, the more encounters occur. This does not mean sharks have changed. It means our presence has. Understanding this shift is key to understanding modern shark attacks. Sharks are not the monsters we imagined, but they are not harmless either. In the next section, we will explore why shark attacks happen, what triggers them, and how environmental changes are increasing encounters between sharks and humans. The truth becomes even more complex. Shark attacks do not happen randomly. They are the result of specific conditions coming together at the wrong moment. Despite what movies suggest, sharks do not patrol beaches looking for humans. Instead, attacks usually occur when sharks are already feeding or investigating their environment. There are three major factors that increase the likelihood of shark encounters. The first is human behavior. The second is environmental change. The third is food availability. Understanding these factors explains nearly every recorded shark attack. Humans are spending more time in the ocean than ever before. Surfing, paddleboarding, open water swimming, diving, and fishing have all increased dramatically in recent decades. This means more humans are entering shark habitats. Sharks have not moved closer to humans. Humans have moved closer to sharks. Certain activities increase risk. Surfing creates silhouettes that resemble seals when viewed from below. Splashing mimics the movement of injured prey. Wearing shiny jewelry reflects light like fish scales. Dawn and dusk are particularly dangerous times. These are peak feeding hours for many shark species. Visibility is low. Sharks rely more on senses other than sight. Mistakes are more likely. Most shark attacks occur in shallow coastal waters, not in deep ocean environments. This is where humans and sharks overlap the most. Water clarity plays a major role in shark behavior. After storms, runoff carries debris and nutrients into the ocean. This attracts fish, which attracts sharks. Murky water reduces a shark's ability to visually identify prey. In these conditions, sharks rely more heavily on electroreception and movement. This increases the chance of misidentification. Temperature also matters. As ocean temperatures rise, shark ranges expand. Species that once stayed in tropical waters are now appearing farther north. This brings sharks into new areas where humans are unaccustomed to sharing space with them. Climate change is not making sharks more aggressive. It is changing where and when encounters occur. Overfishing has dramatically altered ocean ecosystems. Many of the fish species sharks rely on have been depleted. When natural prey becomes scarce, sharks are forced to explore new areas and new food sources. This does not mean sharks begin hunting humans, but it does increase the likelihood of investigative behavior. A hungry shark is more likely to approach unfamiliar objects. Fishing activities also attract sharks. Blood, bait, and struggling fish create strong sensory signals. In some areas, sharks have learned to associate boats with food. This conditioning increases encounters. Humans are not being hunted. They are entering an ecosystem under stress. The fear of sharks far exceeds the actual risk. Worldwide, fatal shark attacks are extremely rare. You are far more likely to be injured by a dog, a deer, or even lightning. Yet sharks inspire a unique level of fear. This fear is psychological. Sharks attack silently. They come from below. They are hidden. The human brain is wired to fear unseen threats. Movies and media amplify this fear. Every shark attack becomes global news. Shark encounters that end peacefully are rarely reported. This creates a distorted perception of risk. Fear does not reflect reality. Many myths surround how to survive a shark encounter. Some suggest playing dead. Others suggest punching the shark. Some recommend using electronic devices or repellents. The truth is more nuanced. Most sharks are not aggressive toward humans. Maintaining eye contact can deter some species. Avoiding sudden movements reduces curiosity. Leaving the water calmly is often the best response. Sharks rely on surprise. Once detected, many sharks lose interest. There is no guaranteed method to stop a shark. The best defense is prevention. Understanding shark behavior saves lives. Sharks are not identical killing machines. They have individual behaviors. Some are bold, some are cautious, some avoid humans entirely. Researchers have identified individual sharks that repeatedly approach boats. Others disappear for years. This individuality challenges the idea that sharks are mindless predators. They learn, they remember, they adapt. Sharks are not machines. They are animals responding to their environment. Popular culture has shaped how sharks are perceived. Movies portray sharks as revenge-driven monsters. In reality, sharks do not feel hatred. They do not plan attacks. They do not seek humans. This misinformation has consequences. Fear leads to calls for culling. Culling reduces shark populations. Reduced shark populations damage ecosystems. Killing sharks does not make beaches safer. It makes oceans weaker. Not every ocean incident involves a shark. Injuries caused by boats, jellyfish, or other marine animals are sometimes misattributed to sharks. Sharks become scapegoats. This reinforces fear and misunderstanding. Accurate science is often drowned out by sensationalism. Understanding sharks requires separating fact from fear. Shark attacks are rare, but human impact on sharks is not. In the next section, we will explore the greatest threat sharks face today. It does not come from the ocean. It comes from us. Sharks have survived mass extinctions, asteroid impacts, ice ages, global climate shifts, but they are now facing their greatest threat in history: humans. Every year, more than 100 million sharks are killed worldwide, not for survival, not for balance, but for profit. The scale of this destruction is difficult to comprehend. Entire shark populations are collapsing faster than scientists can study them, and most people have no idea it's happening. Shark finning is one of the most destructive practices in the ocean. Sharks are caught, their fins are cut off, and their bodies are thrown back into the water, still alive, unable to swim, unable to breathe. They sink to the bottom and suffocate. All of this is done for one reason: soup. Shark fin soup is considered a luxury item in some cultures, but nutritionally it provides no real benefit. Its value is symbolic, not scientific. Millions of sharks die for a bowl of soup that offers nothing essential. This practice targets sharks regardless of species, age, or population status. Pregnant females, juveniles, endangered species. None are spared. Not all shark deaths are intentional. Many sharks are killed as bycatch. They become trapped in nets meant for other fish. Long lines stretch for miles, baited with thousands of hooks. Sharks bite the hooks and drown. Even when released, many do not survive. Bycatch kills millions of sharks every year. This silent destruction often goes unnoticed. There are no headlines, no outrage, just numbers. Sharks cannot recover quickly from population loss. Most species reproduce very slowly. Some take more than a decade to reach sexual maturity. Some give birth to only 1 or 2 pups every few years. This strategy worked for millions of years, but it cannot keep up with industrial fishing. When shark populations collapse, recovery can take decades, sometimes centuries. In some regions, certain shark species have declined by more than 90%. This is not a warning. This is already happening. Sharks sit at the top of the marine food chain. They control populations below them. When sharks disappear, mid-level predators increase rapidly. These predators consume herbivorous fish. Without herbivores, algae grows unchecked. Coral reefs suffocate. Entire ecosystems collapse. This process has already been documented. Removing sharks does not create safer oceans. It creates unstable ones. A living shark is worth far more than a dead one. Shark ecotourism generates billions of dollars globally. Divers travel across the world to see sharks in their natural habitat. In many regions, sharks provide sustainable income for local communities. Once sharks are gone, that income disappears. Killing sharks destroys long-term economic opportunity. Protecting sharks creates it. Some countries have established shark sanctuaries, fishing bans, protected zones, international agreements. These efforts work. In protected areas, shark populations stabilize and begin to recover. But enforcement is difficult. Illegal fishing continues. Demand remains high. Conservation is a race against time. Public fear influences policy. After shark attacks, calls for culling increase. But science shows that culling does not reduce attacks. It damages ecosystems. Fear-driven decisions ignore data. Effective conservation requires education. Understanding sharks reduces fear. Reducing fear saves sharks. Climate change is reshaping the oceans. Rising temperatures alter migration patterns. Prey species move. Sharks follow. This brings sharks into new regions. It also disrupts breeding grounds and nurseries. Sharks are resilient, but not invincible. Climate change compounds existing threats. Unlike dinosaurs, sharks will not disappear suddenly. There will be no dramatic moment, no final image. They will simply become rarer, then absent, and most people will not notice until the damage is irreversible. Extinction does not always announce itself. Sometimes it happens quietly. Sharks are not the villains of the ocean. They are its guardians. In the next section, we will explore the intelligence, social behavior, and unexpected complexity of sharks. The side of sharks few people ever see. For a long time, sharks were believed to be driven purely by instinct. No learning, no memory, no problem solving. That assumption was wrong. Modern research has revealed that sharks are far more intelligent than once believed. They can learn from experience. They can remember locations. They can modify behavior based on outcomes. Some sharks learn to associate specific sounds with food. Others learn to avoid certain areas after negative encounters. This is not mindless behavior. It is adaptation. Many shark species migrate thousands of miles every year. They return to the same feeding grounds, the same breeding areas, the same nurseries. This requires memory. Some sharks use Earth's magnetic field to navigate. They detect subtle changes in magnetism and use it as a map. This natural navigation system rivals modern technology. Sharks do not wander aimlessly. They know exactly where they are going. Sharks were once thought to be solitary animals. But many species display social behavior. Hammerhead sharks form massive schools. Some species establish dominance hierarchies. Others recognize individual sharks over time. These interactions reduce conflict and conserve energy. Social behavior increases survival. Sharks are not isolated killers. They are part of complex social systems. Sharks do not vocalize, but they communicate. Body posture, swimming patterns, fin positioning. A lowered pectoral fin can signal agitation. A sudden arching of the back is a warning. Most shark encounters with humans include warning signs. When these signals are ignored, encounters escalate. Understanding shark body language saves lives. In some regions, sharks have learned to associate boats with food. Fishing vessels create strong sensory cues. Sound, vibration, smell. Sharks remember these patterns. This learning is not aggression. It is adaptation to human presence. In other areas, sharks actively avoid humans. Past negative encounters shape future behavior. This is learning. Researchers have documented consistent personality traits in sharks. Some are bold, some are cautious. Some explore new objects, others avoid them. These traits remain stable over time. This individuality challenges the idea that sharks are interchangeable predators. Each shark responds differently to the same situation. Experiments have shown that sharks can solve simple problems. They can learn routes through obstacles. They can recognize shapes. They can remember solutions. This cognitive ability supports survival in changing environments. Sharks are not just strong, they are adaptable. Sharks experience stress. Elevated stress hormones have been measured in captured sharks. Prolonged stress weakens immune systems. It reduces reproductive success. This is why captivity is challenging for many species. Sharks are not machines. They respond physiologically to their environment. When animals are seen as unintelligent, they are easier to destroy. Misunderstanding shark intelligence has justified mass killing. Science tells a different story. Sharks are complex animals playing a critical ecological role. Killing them blindly is not control. It is ignorance. Some shark species adapt to captivity. Others do not. Observations in controlled environments have revealed learning, memory, and behavioral flexibility. But captivity also highlights limitations. Sharks evolved for vast open spaces. No tank can replicate the ocean. Captivity teaches us about sharks, but it also reminds us where they truly belong. The image of the shark as a mindless killer is outdated. Sharks are aware, responsive, adaptive. They are predators, yes, but they are also essential intelligent components of a living system. Understanding this changes how we interact with the ocean. Sharks are not only intelligent, they are also deeply connected to the health of the entire planet. In the next section, we will explore how sharks shape ecosystems, why their absence changes everything, and what happens when balance is lost. Sharks do more than hunt. They shape ecosystems. As apex predators, sharks influence the behavior of every species below them. Their presence alone changes how other animals move, feed, and reproduce. Fish avoid open areas. Herbivores move constantly. Prey species stay alert. This is called the ecology of fear. Sharks do not need to kill constantly to control ecosystems. They regulate through presence. When sharks disappear, changes ripple downward. Mid-level predators increase. Smaller fish decline. Herbivores disappear. Without herbivores, algae spreads uncontrollably. Coral reefs suffocate. This chain reaction is known as a trophic cascade. It has been documented in multiple oceans around the world. Sharks are the first link. Remove them, and everything else follows. Coral reefs support nearly a quarter of all marine life. They protect coastlines, support fisheries, sustain tourism. Sharks help keep reefs alive. By controlling predator populations, sharks allow herbivorous fish to survive. These fish eat algae that would otherwise smother coral. Without sharks, reefs collapse. Protecting sharks protects reefs. Sharks indirectly help fight climate change. Healthy marine ecosystems store carbon. Seagrass meadows and reefs absorb massive amounts of carbon dioxide. When ecosystems collapse, stored carbon is released. By maintaining balance, sharks help stabilize these systems. Their role extends beyond the ocean. It affects the planet. Some believe that other predators can replace sharks. They cannot. Sharks evolved over hundreds of millions of years to fill their role. No other species hunts the same way. No other species exerts the same pressure. Once sharks disappear, the gap remains. Ecosystems do not adapt quickly enough. Collapse follows. Over 3 billion people rely on the ocean for food. Millions depend on fishing for income. Healthy oceans mean stable food supplies. Sharks indirectly support fisheries by maintaining balance. Killing sharks undermines long-term human survival. This is not environmental idealism. It is practical reality. Not all news is negative. Where sharks are protected, recovery happens. Marine sanctuaries show increased shark populations. Fish numbers rebound. Ecosystems stabilize. These areas become more productive, not less. Protection works. Modern technology allows scientists to track sharks in real time. Satellite tags reveal migration routes. Data identifies critical habitats. This information guides protection efforts. Science replaces fear with understanding. Understanding leads to coexistence. Fear thrives in ignorance. Education changes perception. When people understand sharks, they fear them less. Reduced fear leads to better policy. Better policy leads to recovery. Documentaries play a critical role. Knowledge protects what fear destroys. Humans cannot dominate the ocean. We can only coexist. Simple changes reduce risk. Understanding migration seasons. Avoiding peak feeding times. Respecting habitats. Coexistence saves lives, both human and shark. Ignoring the problem has consequences. Shark populations continue to decline. Ecosystems weaken. Food security is threatened. Doing nothing is a decision, and it is the most dangerous one. The future of sharks is not predetermined. It depends on choices made today. Protection, education, responsibility. The ocean remembers what we do. We have explored fear, myth, science, impact. Now, in the final section, we confront the ultimate question. What kind of relationship will humans choose to have with sharks? And what kind of ocean will remain when that choice is made? The greatest misconception about sharks is not that they are dangerous. It is that they are enemies. Sharks are not opposing humanity. They are not competing with us. They are not invading our space. We entered theirs. For hundreds of millions of years, sharks existed without us. They shaped oceans. They stabilized ecosystems. They maintained balance. Human fear rewrote that story in less than a century. Fear spreads faster than facts. A single shark attack is remembered. Thousands of peaceful encounters are forgotten. Fear simplifies reality. It turns complex animals into symbols. Sharks became symbols of danger. But fear does not protect oceans. It destroys them. Science does not deny risk. It explains it. Risk exists when habitats overlap. Risk increases with misunderstanding. But risk can be reduced. Knowledge changes behavior. Behavior changes outcomes. Coexistence is not about eliminating sharks. It is about understanding them. Sharks teach a difficult lesson. Nature is not gentle. It is not cruel. It is balanced. Remove one piece, and the system weakens. Sharks are not exceptions to this rule. They are proof of it. Humans dominate environments quickly. Technology gives us power faster than understanding. Sharks did not evolve to withstand industrial fishing. They did not evolve to survive global demand. Power without restraint breaks systems. The ocean is showing us that limit. The next half-century will determine the fate of sharks. Protection can allow recovery. Indifference will ensure collapse. This is not speculation. Population models already show the outcome. Action leads to balance. Inaction leads to silence. Imagine an ocean without sharks. No silhouettes below the surface. No pressure shaping ecosystems. No balance. Fisheries decline. Reefs die. Food chains unravel. The loss would not be symbolic. It would be practical and irreversible. Humans are not separate from the ocean. Weather systems depend on it. Food systems depend on it. Climate regulation depends on it. Sharks support these systems indirectly. Their loss would affect everyone, even those who never see the ocean. Protecting sharks is not about romance. It is about realism. No apex predators means unstable systems. Unstable systems mean collapse. Nature does not negotiate. It responds. Perception is changing. More people understand sharks today than ever before. Education works. Science works. Respect works. This shift is slow, but it is real. Change does not require heroism. It requires awareness. What we support, what we share, what we tolerate. Small choices influence large outcomes. Sharks are not the villains of the ocean. They are its backbone. They do not dominate through violence. They dominate through balance. The ocean does not need humans, but it cannot survive without sharks. Fear created the myth. Science revealed the truth. The question now is simple. Will we protect what sustains life, or destroy it out of misunderstanding? If this documentary changed how you see sharks, subscribe to Wild Facts. Because nature is not a story we tell. It is a system we depend on. And nature is crazier than fiction.